Section 9.1 talks about vectors in two dimensions. A vector is a quantity that has both or possesses both a magnitude and a direction. So two things we need to maintain for a vector for it not to change. We need to maintain its direction and its magnitude. If you think of a vector, it looks like a ray. It has an arrow indicating direction. So if I call this vector v, so vectors normally the notation is you put an arrow on top. Also, if you know this point, initial point, that's where the vector begins, and b is the terminal. Remember, this is not a ray. The arrow is just indicating the direction that this is moving in. The way you would think of that as in an application, think of those as like moving belts, you know, kind of like uploading certain boxes on a plane, or uploading that at a UPS truck, where you get this belt that moves. It has a certain length, we call it magnitude, and it has a certain angle, we call it direction. If you know the beginning and the terminal point, you could call this vector AB. Those two are the same thing, but AB is a better representation of vector B because it tells you where to start and where to end. Excuse me. You could also write V. If you make this a bold letter, those are reserved for vectors. So those three are saying the same thing. The magnitude of the vector, you're going to figure this out, that's our R. And the direction of the vector, you're going to figure that out, that is theta. For now, we're going to talk about the geometric description. It's important for you to see this visually. Then we go algebraic, and then at the end, we're going to tie what we learned between magnitude of the vector and R and the direction and theta. So I have a first example. This is for visual connecting what this means, and it's very important to figure out what you're finding. Use the vectors on the right to sketch the resultant. What's the resultant? So remember, we're thinking of these vectors as moving belts. You drop an item at the initial point and you pick it up right there. Well, if you want another belt to be added to this, you attach the second belt right where the first one drops off. So terminal to initial. If I start with A, I'm going to do A right here. You could use the scale any way you want. I'm going to start here at the center. So if I start at the center right there, and again, it's up to you. If I take vector U, vector U right there is in green. Vector U, any item that you drop off at the base, it moves 3 units to the right, 2 units up, or 1 unit up. So U first, you go U 1, 2, 3, 1 up. U is right there. Let me use my 3 to the right, 1 up. Now my item is right there. For you to figure out how these connect, take V, which is the blue, and attach it exactly where this drops off. Wherever this drops off, what does V do? V shifts up 3 units. Any item you drop off, it moves up 3 units. So anytime you want to figure out what the outcome of this is, we call that the resultant. Where do I drop off my item? I drop it off right there. And if I go in a straight path, where do I pick that up? Whatever those vectors stand for, that would be my resultant. So if this is my vector U, this is my vector V. Since this is where the first one dropped off, the second picked up, this is simply U plus V, whatever those are. And that's how it works. If I look at W is in purple. 2W. I'm going to start that vector, and again, you could start anywhere you want. Normally you start at the origin, but let's say we start right here again. What W does, any item that you drop on W, it ends up being there. That's really shifting 1, 2, 3 down, and 1 to the right. So any item, when I pick 1W, that's going to be 1, 2, 3 down, and 1 to the right. And multiplied by 2, you're going to do that again, but you're going to pick it up from there. 1, 2, 3 down, 1 to the right. It went off board, so I'm going to shift this up. Again, that's why I made it optional. So I'm going to shift down again. 1, 2, 3, and 1 to the right. So that would be my resultant. Meaning, I drop off an item right there, I'll pick it up right there. That will be W plus W, or 2W. If I go for example 3, I'm going to start with Z. Whenever you drop any item at Z, it just shifts it 2 to the right. So let's say we're starting right here. If I need to shift that, I would. Let's say I'm starting right there. That's 0, 0. So anything you drop there, it's going to end up being right there so far. That is W. Now minus V. What's minus V? Reversing the order of V. V, any item you drop on V, it ends up being 3 units above. What do you think minus V does? Any item you drop on minus V, instead of going up, it's going to run down 1, 2, 3 units. And now my item is right there. And what would W equal? Well, W is the purple. 3 down. So I do need to adjust that and shift it up just a bit. Let's say it's right here. So now I'm going to go with the purple. The purple, 3 down, 1 to the right. 1, 2, 3 down, 1 to the right. That's what W always does. It's a fixed, you can't change its length. You can only reverse it if you want. What's the resultant? The resultant of all of this, where did I drop off my item? If I go in a straight path, how do I pick it up? That's literally my resultant, which is the sum of those four. So it's important for you to see this geometrically and what it means. It doesn't matter how many vectors you apply. You drop a baggage, you're trying to figure out what's the quickest way for me to go in a straight path and pick it up. How about D? So I should label those. This was A, B, C, D, E, and I'm going to label the last one F. And here they are. If I go to D, D starts with V. V is the blue. So I'm going to start on the bottom. I'm going to start, well, let's see. V is the blue. Let's say we start right here. Let's say that is the X and the Y. 3 units up. Now my item, if I'm going to go in a straight path, it's right there. It's at this location. That is V. W, U. U is the green. What does the green do? The green shifts 3 units to the right, 1 up. 1, 2, 3 to the right, 1 up. So now my item is right there. And then I would move my W. What's W? W shifts 3 down, 1, 2, 3 down, and 1 to the right. Now my item's right there. And then Z. Z, all what it does, it shifts any item 2 units to the right. What is all of this mess? Well, you really don't care about any of this mess. The resultant, where did you drop off your item? And where is it right now? Go in a straight path. Oops, it didn't register. And guess what? This vector here is V plus U plus W plus Z. So visually, it's very important for you to get this out of the way. You need to figure that out in calculus. How about W? How about E? Well, E, the way we do it, we start with W, take an item, and start with W. Let's say we're starting right there. W shifts 1, 2, 3 to the right, 3 down, 1 to the right. My item now is right there, assuming this is the origin. Okay, then what? Then negative 2z. What does z do? Z shifts any item 2 units to the right. That's positive. If I reverse it, that's going to shift 2 units to the left, and then since there's 2 of them, double that. So now my item's right there. And then after that, what am I going to do? I'm going to add U to it. U is green. If I attach the green right there, that's going to shift it 3 units to the right, 1, 2, 3, and 1 up. Now what? If I want to go in a straight path and pick this up, all what I have to do is go down 2 units, and that's the result. Remember, the resultant is always what those are. The overall. Meaning, if I figure out what did you do first and where did I end up being at. And if I go for the last one, that's going to be a bit of fun to do. And that starts with negative V. V is the blue. So negative V, assuming the origin is right there. Negative V, that means I go, instead of up 3, 1, 2, 3 down. I'm right here right now. This is where I dropped off. And here's where I am right now. Negative U, that's the green. If U moves 3 to the right, 1 up, negative will do the opposite. Will move 3 to the left, 1 down. So just the same thing, just reverse the order. Now my item's right there. Then I have negative W. W is the purple. Negative W. W moves 3 down, 1 to the right. Negative that will move 3 up, 1 to the left. So kind of like reversing the order. So now my item is right there. And lastly, I will go for a negative Z. What Z always does, shifts 2 units to the right. Well, it's going to shift 2 units to the... Well, you know why I have to move this again. It's kind of... I'm going to shift this to the left a bit so it fits. So Z shifts 2 units to the left. Now my item's right there. How do I find the resultant? Go in a straight path from where you dropped off your baggage, where to pick it up. That's what all of those are. And there it is. That's the geometric description. Algebraic description, we're going to do everything that we just did, but we're going to do it using algebra. That takes a bit longer. And here's how it works. Algebraic interpretation. Well, given any 2 points, initial and terminal. Initial point and terminal point. We assume the origin is the initial. That's called a position vector, also component form of a vector. The way it works, if I write a vector ai plus bj, this is the I and this is the j. Right? Don't mix the I with the complex numbers. The I only indicate the x direction and the b indicate the y direction. So, the point 2, 3, 2, 1 is right there. That's A. 3b, 1, 2, 3, 1, 2, 3, 4, 5. The original vector looks like this. What I want to maintain its direction and its magnitude. So the way to do that, if I call this vector AB, that would be component-wise. So this is component-wise. This is using I and j. That would be, if you look, end minus beginning. It is x2 minus x1 for the I, 3 minus 2, and y2 minus y1, again, terminal minus initial always end minus beginning. 5 minus 1. So AB is a lot more useful, even though they possess the same thing. If you put it in component form or use position vector, you're saying AB is either 1, 4, which means move 1 to the right, 1, 2, 3, 4. This vector right here and AB are the same. Why is that? They have the same length and they have the same angle with the x-axis. You could pick a vector and move it anywhere you want as long as you maintain its length, which is magnitude, and the theta, which is direction. I could write this as 1i plus 4j, by the way. I know it's a bit messy after complex numbers. Same idea, but they have different applications. So again, if I look at the point A, that's 1, 2, 3, 1. There's A. And B is at negative 2, 1, 2. So if I draw my vector starting here and terminating right there, again, if I want to write this in a position vector or write it using component form, AB would be end minus beginning, negative 2 minus 3 and 2 minus 1. So AB would be a negative 5, 1 or negative 5A plus J. Which tells you, kind of like we were doing, if you want to do exactly what this vector does, wherever you start off, move 5 units to the left, 1, 2, 3, 4, 5, and 1 unit up. And those two vectors are identical, except this one starting at 0, 0. And if you really glance at that and count, you will count 1, 2, 3, 4, 5, and 1 up. So you're not changing anything really. Now, what if I was looking at the following? Okay, I'm almost done with this. I have 3 more examples, so we're going to do half of it today. So I have a vector 1, 3. It says, given vector 1, 3, sketch the representation of the vector given the initial point. So what does that mean? Suppose this vector starts at 0, 0. Then you would move 1 to the right, 1, 2, 3 up, and there it is. If you start at 0, 0, that's vector 1, 3. Or I could say vector 1 is, V is I plus 3j. Doesn't matter. What if this vector was to start at 2, negative 1? If this is my starting point, then the vector is kind of like you move that belt anywhere you want. If you were to put it right there, it's going to move 1 to the right and 3 up. And you could move it anywhere you want. And what if I wanted to start this at negative 4, negative 2? It doesn't matter. Still, I'm going to move 1 to the right and 3 up. And there it is. Now, the last part I want to conclude before I stop this video. We'll pick this up in our next video or next lecture. If you're given vector v and vector w, if you want to add the components, it turns out you could add the I to the I and the j to the j. You could use component form or AI plus BJ. I forgot what was the name. If you want to subtract, you could do the same. And if you multiply a vector by a quantity, you end up multiplying both of its components. So when I say 3w, that's 3. What is w? I like the component notation because I don't like to write ij, but it doesn't matter. Where's w? W is negative 2, 1. So that would be negative 6. You multiply each component by that. And there it is. That's what 3w would look like. And if I wanted to take w plus v, well, w is negative 2, 1. V is 1, 3. So I would add those. Negative 2 plus 1 is a negative 1, and 1 plus 3 is a 4. That would be it. That simple. And if I wanted to take 2w, well, 2w will be 2 times, this is negative 2, 1, minus 3 times v, and v is 1, 3. So that would be negative 2, negative 4, 2, minus 3, 9. And that would be negative 4 minus 3 is negative 7. 2 minus 9 is negative 7. Just a coincidence. And that would be it for this video. We'll pick this up in our next lecture.